When you first start Maple, you will see the Start page. This page points you to a variety of resources for both new and more experienced users. Click on the New Document icon on the top left of the page to open up a blank document. Let's start by typing in some math into our document. We'll type in something as simple as 1 plus 2, then we'll press the return key in order to see the result returned to us on the next line. Now you can also have the result returned to you on the same line. Say if we enter an expression, something like x minus 5 plus 2, then we'll press Alt-Enter. We'll get the result returned to us on the same line. Maple's context panel can be used to perform a wide variety of operations. So say if we put our cursor back here on this expression, the context panel is offering up various operations that are relevant to that expression. So we can go to the context panel, we can choose integrate with respect to x, and we'll get a result of integrating this expression here with respect to x. We can then continue using the context panel for more operations. So with this expression now being our focus, we can go to plots and make a 2D plot. We can also observe that math is live in Maple. So if I go back to the start of this expression, I'll change it to be 2 times x minus 5 plus 2. If I then highlight this entire line and hit this button up here, which is the single exclamation point, this re-executes all these expressions and we'll get an update for each one of these steps along the way. Let's enter another expression. Let's do something like x squared over 2 plus 3x. Alright, so with this expression, we can actually go over here to the context panel. We can look at things like the smart pop-ups, which are at the top. Now these are previews of applying certain operations to this expression. We can, for example, see previews of what the 2D plot of this expression would look like, what factoring would look like, or how completing the square would result in this following result. Maple calculates exact answers. For example, fractions stays fractions. If we enter two fractions here and add them up, we'll see an exact result, 5 over 6. Maple can also calculate numeric approximations. If we then take this 5 over 6, go to the context panel and choose approximate to 5 digits, this is a numeric approximation of that exact result we returned before. If the expression you enter contains any decimal approximations already, such as the 0.5x here, Maple will return the answer in that same format. Using the number format control in the context panel, you can change the display of the result to have different formatting. Here, for example, we can choose scientific notation. Let's talk about some more ways to enter math. Maple's palette system has over 1,000 different symbols and templates available. You can use these as kind of a pre-built template. So for example, if we were to open up the calculus palette, we can insert a definite integral. Then we can start walking through this template by simply entering in values. I'll press 0, I'll press tab to move up to the next value, press 1, and we'll type in x, shift 6, squared, press tab again to do this with respect to x, and hit return. There's the result for the integral. If you find that you use any of these palette entries very frequently, you can add these to your favorites palette by simply right-clicking on the palette entry and choosing Add to Favorites palette. This is especially useful for some of the common symbols, such as pi, where we can add this to our favorites palette, and we'll see these in the favorites palette up on top. Speaking of pi, there are a couple ways we can enter it easily. We can use the common symbols palette to insert it, or we can type it in from our keyboard. If we enter in capital P, pi, and then we press the escape key, we can use the command completion dialog in order to insert that symbol. We can use command completion to complete other commands too. If we were to type in int, which is the integration command, hit escape, we could then use the command completion template to insert the definite integral template. Here we again can type in 0, tab 1, and fill out the template accordingly. Here are some more important things you should know about Maple. Maple is case sensitive. If I type in lowercase x plus capital X, you'll notice that this is returned to us as a sum of x plus capital X. If we do x lowercase plus lowercase x, that comes back as 2x. So Maple in this case is being case sensitive. What's more, for entering multiplication, if we do 3x, we do actually insert an implicit multiplication symbol here. So this is 3 times x. This is a very important distinction in Maple. I'm going to spend a little bit more time here. So 3 times x does actually insert the space. So we do have a space between here, so there's an implicit multiplication happening. If we enter something else in, something like xy, You notice there's no space between these two, so this becomes just a variable named xy. However, if we do xy plus x space y, then we'll have the implicit multiplication between x and y. This may not be immediately apparent, but it will be if we do something like differentiate this result with respect to x, xy, or y. To differentiate this with respect to xy, you'll see that we just get back 1. If we go back here, click on this term, differentiate it with respect to x, we get y. So these are very, very important distinctions here, that we use a space to imply multiplication, or if you want to make sure you're very explicit about it, you can also just do Shift 8 and just do a star symbol, so x times y plus xy whenever you're entering in any values that you want to multiply together. The symbol completion mechanism provides an alternative to palettes for entering symbols. As an example, let's try entering the square root of e to the power of x plus pi squared. For the square root symbol, enter sqrt, square root, then press the escape key. You can notice from the command completion menu we can choose the top one here, square root, and this will insert the square root symbol. Next, type e. This is an important one to notice a difference here, that we see now that e is slanted, it's italicized. So this is actually the variable e, it's not the exponential constant. So let's press escape again on e. We can choose exponential e, and we now see that the e has changed to now having no italic. So we have e to the power of x, pull right cursor over, do plus, pi, type in pi, hit escape, choose the constant pi from the command completion menu, and we'll do squared. Maple understands familiar mathematical notation. For example, if we enter in y double prime plus y prime plus y is equal to 0, Maple understands this is a differential equation in y of x. If we then take this expression, we go over here, we can go to solve dE with respect to y of x, and there's our solution. A couple more important parts of the Maple document. If you enter in an expression, something like here pi squared plus square root of x, you notice on the right side there's this number 1. This is an equation label. This corresponds to this value that you see on this line. If you press Ctrl L, this will allow us to reinsert that equation on a separate line. So here I can insert the equation label 1. I can multiply that by, say, x squared, hit return, and there's our result. Something else that's very important in Maple is being able to assign values to variables. We do so in Maple using the colon equals operator. Here we can do x is equal to 1, we can do y is equal to 2, or we can declare z to be a function. We do so by doing z colon equals, and we can make this a function of, say, w, and then we'll just do a dash and a forward arrow to make an implication here. So we're applying w onto w squared, and this makes z into a new function. So when we enter in z as a function, we can do z of 2, hit return, and we'll get the result back of 4. After you've declared some variables, it's possible to see their current values in the variable palette. We'll open this up over here on the left side, and you'll see that the values here are x1, y2, and z is this function here of w. In Maple, you can combine math and text in the same paragraph to help formulate mathematical sentences. Let's start by entering a simple computation. We'll again use a template from the expression palette, and we'll just do x cubed plus x squared plus x, press tab to move through the template. This will be dx, and I'll use the Alt-Enter keystroke in order to have the result returned to me in the same line. Now what I want to do is I want to add some text before this line. So I'll just put my cursor right at the start of the line, and then I'll press F5 on my keyboard. This switches from this math mode to a text mode. You can kind of see this up here in this toolbar. I'll press this again just so everybody can see it. So F5 switches from math to text. So I can type in something like the answer of this integral, and then I can go and I can click in the middle of this integral. I can remove the equal sign, and I can type in is, and then we'll move to the end of this row, press F5, and add a period. Now, as before, we did say that Maple's math is live. I can go back here and change this to 2 times x. I'll then grab this whole line, highlight it, and use a single exclamation point in order to re-execute and update this sentence accordingly. You can also make Math in a Maple document inert. This means that when you enter it, it won't be executable. So let's take this same expression as before. I'll grab this from the line above, I'll copy it down. We'll copy it to this line here. So you can see by this light blue background that this is in fact live math. If I hit return here, I'm going to get a result. However, if I go back and I press Shift F5 on this, it'll change the background color to this gray. And if I hit return now, it'll just be inert. So this means I can't execute it. If I choose this and try to execute, it won't execute. So this is something you can use then for typesetting. So say if you want to just use this as typeset math in the middle of your document, you can use the Shift F5 keystroke in order to add in mathematics that is not executable by default. So next, let's talk about plotting in Maple. So the fastest way to generate a plot is to use the context panel. So if I've got an expression here, something like sine of x squared, I can go from this expression over to the context panel, go down to plots, press 2D plot, and that's a 2D plot of this expression here. Now one thing to notice when you do generate a plot in Maple is that if you click on that plot, you'll see the plot toolbar. So from this plot toolbar, we can do things like zoom in or zoom out on the plot. We can also do things like turning on our point probe. So we can use the point probe to move around and see various points along the line. It's important to notice that these controls exist for plots, because in a second we'll also be using the drawing toolbar to annotate some plots. But first, let's generate another plot. So let's enter something like sine of x over 2 this time. We'll do the same thing as we did before. We'll use this expression here. We'll go over to plots, 2D plot, and this generates a different curve than what we saw above. So one of the most common things you might want to do is you might want to combine different plots to see how two different expressions look when they're contrasted. So to do so, one quick way you can do it is you can go up here, you can grab this expression, I can press Control on my keyboard, and I can drag it down, I can drop it right on top of this other plot. So now that we've got a couple plots together, it may also be useful to do things like be able to annotate plots. So I can go, I'll just grab this expression here, I'll copy this into my computer's memory. I'll go down here, I'll add a text box. I'll paste in sine of x squared, so that way we've got the text there. And then we can move this text up, we can put it right up here, right by the other line if we wanted to. We can also do things like we can add some arrows in order to point to the lines. We can customize this further using other controls all up here in the drawing toolbar. So this is all options that you might want to do when you're annotating or working with plots. So another nice thing that you can do with plots is if you generate a plot, you can export it. So again, if I go up to a plot, click on that plot, you notice that you can go to the export menu over here in the context panel and export it to a number of different file types. So 3D plots are just as easy to generate. If we have an expression, something like sine of x times y, we can go over to the context panel, choose 3D plot with respect to x and y, and there's our 3D plot. So by default for 3D plots, you can just rotate them. But again, as we saw before, the plot toolbar, there's a lot of other controls here for panning, for zooming, and setting your orientation. One other item that you'll notice is that when you have generated a plot, the options over here in the context panel have actually changed. So using these options over here, we can start doing things like customizing the existing plot. So here we can change the color scheme. We can change our transparency levels. There's a lot of different controls. All of these correspond to common options for different plots in Maple, and they make it easy to customize any of the plots that you generate. So speaking of being able to create plots, the Plot Builder is an excellent tool for easy creation of plots. Again, we'll start with an expression, something like x squared plus y squared. We'll choose Plot Builder. It's right at the top of the list over here in the context panel. And this opens up our Plot Builder, and it opens up inside of the context panel. So the entire context panel has changed for us. From the context panel, we can choose a variety of different plots. Let's start by choosing a 2D contour plot. And this is what a contour plot of x squared plus y squared looks like. Let's change it up. Let's go over to a 3D plot instead. And this is a 3D plot of that same expression. From this menu, we can now customize things like our 3D options. We can go over here and add, say, a title. I'll just hit return at the end there. And back in our basic options, we can change the ranges for our x-axes. We can change some of our shading schemes. So let's just change the color here. I like using this set U1. And then we'll use a surface instead of the surface wireframe. We'll go into our 3D options. We'll make this slightly transparent just so we can kind of see through it. Another nice feature of the Plot Builder is you can actually use this to generate commands. So if I go back to the main screen here, basic options, I'll go to show command, and this is the command that you'd use to regenerate this exact plot here. So if I go down to another line and copy this out from this box here, paste it in and hit return, you're going to get that exact same plot returned again. So the plot builder, it's a great tool for generating, for customizing plots, but it's also a great tool for learning how to use plotting commands inside of Maple. Let's continue talking about interactive tools in Maple. The Exploration Assistant allows you to instantly create interactive mini applications used to explore parameters of expressions. So say we have an expression like this. This is a 3D plot, and the expression here is cos of a times x plus b times sine of y. In this expression, we have two parameters, a and b, as well as two variables, x and y. So to make an exploration for this, where we want to vary values for a and b, all we do is we go over here to the context panel, we choose Explore, and this brings up our assistant dialog. First thing we do is we're going to skip x and y. These are variables, so we don't want to see how they change. We want to see how the parameters a and b change over different expressions. Here we have different controls for their values. So we can change a to be from 0 to 2 pi, and we'll leave b from 0 to 10. We're going to leave everything else the same, and we're just going to press Explore in order to explore the expression. This returns a plot as well as a couple of sliders that control values for a and b. So now if I slide out the value for a as well as b, we can see how this surface changes as we vary values for a and b. So this is a great way for you to find out more about a mathematical expression or the plot of a 3D surface. So again, this is called the Exploration Assistant. You can see a lot more about this inside of our Maple help pages. To get there, you can go to something like !explore, and this will bring you into our Maple help guide. Here you can read more about the Explore command. You can also view examples about Explore. This is a great worksheet right here, Examples Explore. Another way to get into our help system is just to go up here, type in Explore, and that'll bring you into our help. Maple provides many tutors, which are useful for teaching and exploring mathematical concepts in calculus, pre-calculus, linear algebra, statistics, and more. Let's show you an example. So from the menu, let's choose Tools, Tutors, Calculus Single Variable, and Integration Methods. We can enter a function into the function box here, or we can just use the default, sine of x squared. And then what we can do is we can proceed to step through the integration. So as a student, we can use this in order to learn the steps on proceeding through integration problems. If we're not sure how to step, press Get Hint, try rewriting, which would lead us to apply the rewriting rule. We can get another hint, notice the plus in the expression, maybe apply the sum rule. We can get another hint, what's the integration variable, apply next step, apply the constant rule. If we want to skip all the way to the end, press next step, and if we close, we'll return the complete step-by-step solution as well as all of the rules that were applied along the way. So you can see all these on the right side of your screen. Another tip, if you're looking for more task-specific help, go up to the Tools menu and choose Tasks, Browse. This will bring up the Task Browser. You can browse through a large collection of task templates for solving problems from calculus, geometry, differential equations, statistics, and more. Let's again choose one from calculus here, calculus, integral, formal rules. Here we can step through evaluation of an integral using this task. If you're looking for more interactive content in Maple, go to the Tools, Math Apps menu. Math apps and other interactive applications provide demonstrations that illustrate various mathematical and scientific concepts. This Math App Guide provides an overview of all the available applications in many different fields, including discrete math, engineering, finance, statistics, and more. To get an idea of what applications look like, let's scroll down and let's pick a few. Let's start with conic sections. So this is an interactive Maple document. Here we can scroll through this document, we can see the main concept explained, and below there's an interactive section with a 3D plot and a couple of sliders that allow us to move this plane back and forth through this 3D surface. Let's pick another application from calculus. We'll choose Solids of Revolution Volume by Disks. In this application, as a user, we can go in here, we can draw out a line, and we can see it being revolved around an axis over here on the right side of our screen. Let's pick one final application from the engineering section. This is the bouncing ball application. So in this application, we demonstrate how event modeling in the differential equation solving command dsolve can be used to model a ball bouncing on a hilly terrain. The first thing we see here is the definition of the surface. As we scroll down here, we see some of the derivation of the surface, differential equations used, as well as the plots used. At the bottom, we can play this back as an animation in order to model how the ball bounces around between peaks and eventually lands between the two peaks in one of these valleys. While many operations in Maple can be done using the context panel and other interactive tools, some of you may have noticed in that last application that Maple also has a very rich programming language. So let's walk through a couple of examples that talk a little bit more about the Maple language. The first thing I'm going to do is I'm going to insert a matrix. I'm going to use some commands that deal directly with matrices in this example. So let's use the matrix palette in order to insert a custom matrix. I'm going to give this values 1, 2, 3, and 5. This is our matrix. And as we saw before, let's assign this to a variable. Let's assign this to a variable named m. So we'll do m colon equals this matrix. With variable assignment, if I press m anywhere else in my document, the stored value for m will be echoed back to me. So the idea with the Maple language, and what I want to talk about in this last section, is that a lot of commands are available to you from the Maple top level. Before we saw integration, we saw differentiation, we saw plotting. These are all top level commands. But there are also many commands which are available from within packages. So if I start typing out here linear algebra, I'll press tab to command complete that. Linear algebra is a package in Maple. If I press F2 on linear algebra, this will bring me into the help system again, and from here I can read more about the linear algebra package, as well as seeing a full listing of all the commands which are available to you in the linear algebra package. So the first command I want to show you is we'll use linear algebra colon dash. This is going to tell Maple that I want to take a command from the linear algebra package, and we'll use the determinant command on our variable m. This tells us the determinant for m is equal to -1. Now, one of the cool parts about Maple packages is that they're not all loaded by default, but we can load them into Maple's top level by doing with linear algebra. This loads all those commands from the Maple linear algebra package into Maple's top level. And then if I do determinant of m again, I get that same value. I don't have to do linear algebra colon dash anymore. Let's use some other commands from the package. Let's say use Gaussian elimination on m, and there's our result. Or let's use something like transpose on m. There's a result. Now, as one more tip, one more thing I'll mention is that if you're interested in a quick way to load packages, you can go to Tools, Load Package, and just click on any one of the package names here. This is a partial listing of all the packages available to you. You can also click on List All Packages to see a full list of all the available packages in Maple. So this has been a quick guide to get you started in Maple. I want to leave you with a couple more resources. Probably most important is the Maple Help System. You can open the Maple Help System at any time from the Help menu by going up to Help, Maple Help. So from here, you can browse through the entire help system through the table of contents that's on the left side of your screen, or you can search for what you need. A search is as simple as going up to the search bar here, typing in, say, is prime, and opening up a help page that walks you through that command. I'll also mention, if I minimize the help here for a second, you can look for the same commands using the search bar at the top of Maple's interface. If you type in is prime and click, this will bring you back to that same help page. Another way to do this in Maple is by typing in question mark and then the term you want to search for. So question mark is prime will also bring you into the same help page. Another tip, say you've typed out a Maple command, so is prime 2. If you go and put your cursor on that command and press the F2 key on your keyboard, then it will also bring you into the Maple Help System. So there are multiple ways to get into the Maple Help System to ensure that you get the assistance you need when you're working through any one of our Maple commands. If you're just getting started with Maple, the Maple portal acts as a starting place for any Maple user. You'll find it here under Resources, Maple Portal. You'll find there's a lot of different resources here. This is a collection of useful resources for learning about Maple, including getting starting resources. There's how-do-I pages, there's training videos, there's links to the user and programming manuals, there's more examples and applications, there's additional resources for students and educators, and there's a lot of really great content. I think most importantly, you can just start by watching the video you see here. So step 1, watch video. 2, get into Maple Fundamentals Guide. And proceed to walk through the tutorials we have available on this portal.